So yeah, in theory that was supposed to be mildly panic-inducing. The exam is next Thursday, not this Thursday. It says right below it, next Thursday. Mildly panic-inducing because I happened to look at the schedule and realized that it was next Thursday, and that freaked me out. So it's mostly written right now. It should be about 40 questions. The idea is to scale it such that it gets you prepared for the final exam. The final exam is 65 questions in an hour and 50 minutes. So if we scale accordingly, you're looking officially 44 questions for a length to be of comparable size to the final exam. That said, there isn't a whole lot I can ask. It starts to get very, very repetitive as far as the questions that I'd ask. So 40 questions is going to be the target. I might be a little bit under that, maybe a little bit over that, but probably under. I do try to keep exams with calculator required questions being less than 30% of the exam, okay, just to give you an idea. Most of the calculator stuff that you're going to be doing on the exam is fairly straightforward and quick, so it shouldn't be that big of a deal if it's a little bit more than that, but you can expect probably about 30% of those questions to require a calculator. All the homework is now available. I think it's 5 assignments. I could be wrong on that. It could be 6. Based on the amount of time it's taken people to complete the first 3 assignments, and in particular that third one, I'm going to guess it's going to take roughly 6 hours, beginning to end, to do all 5 assignments. Okay? The most recent 3, I guess, assignments are going to take longer because those will actually involve calculations as opposed to just reading and looking at answers. Okay? So expect that the last 3 assignments should be an hour to 2 hours time. So for those of you that have gone through and completed the 3rd assignment, thank you for completing that because that gives me a time estimate to go through and tell everybody else what to expect. There is a practice exam posted, listed up there. I do not post answer keys. I'm an anti-fan of solutions manuals because students have a habit of looking at the answer and going, oh, of course I know what I did wrong because I'm looking at the answer. On an exam, you don't have the answer to look at. So if you build a habit of just looking at the answers, you're not going to actually learn and retain the material when it gets to the exam. So I won't post any answers. I also will not go through and tell you if answers are correct, right? Which is, again, I know a stupid, subtle difference. But I won't. I won't tell you that you're right. What I will tell you is when you're wrong. Okay? You can extrapolate whether or not you were right or not. If I tell you you're not wrong, you can decide, oh, that must mean I'm right. Okay? I know, dumb little thing, but that's what I'll do. I have no problems verifying or going through and looking at answers. So if someone wants to go through and take the whole test, come up with what answers they think are correct, and send them to me, I have no problems checking that in email or in person. Ideally, you would go through and post it to the discussion board. I know that can be a bit nerve-wracking because you're now associating your name with a whole bunch of answers. Okay? If that bothers you, when you send it to me in email, probably what I'll do is copy and paste it out of the email into the discussion board without your name attached to it. And you'll get the same kind of feedback from it. Okay? Kind of makes sense? So if someone wants to be enterprising and help out the whole class, great. If you don't want to be enterprising and help out the whole class, oh well. Right? No problems in either situation. Questions? Okay. We'll move forward. This is just kind of to summarize everything that we've seen so far. So it's all of the significant digit rules. I did make some slight adjustments to them. We've got our addition subtraction rules, our multiplication division, and then also rounding as well. The one thing that I'll point out, which was addressed in the last class, I think it was last class, in rule number 2 of our sig figs, okay, initially it had just said immediately to the left and right of a 0. We found that not to be true. Okay? It's at any place to the left and right. The example given in class, 1002. How many sig figs? We end up with 4, and if we'd followed my initial rules previously, we wouldn't know what to do with the zeros in between. With this adjusted rule, at any place to the left and right, those zeros are now clearly significant. Okay? Questions about that? Okay. So, how do we measure really big and really small numbers? So this is where our scientific, or not scientific, I can't remember what the term is, the SI. What is SI? Was it standard? I don't know. It's our units. Okay? With our metric system units, we can go through and scale our base unit by powers of 10 by using these prefixes, these Greek prefixes. So if I wanted to look at 1,000 meters, I could just write out 1,000, little m, and now I've got 1,000 meters. Okay? But if I want to avoid writing out all of those zeros, what I can do is convert this number into scientific notation, okay, which would mean we'd have 1 decimal point. Do we include any zeros? Do we need the decimal point? No. How many sig figs are in our number 1,000 as written?
1.
There's only 1 sig fig. Why? No decimal point to specify that those zeros are part of the measurement. Okay? So just by writing 1, we've implied our 1 sig fig. We don't need to specify the decimal point. If you want to, it's not going to hurt. Where would it hurt? Decimal point followed by a 0. What's the problem with that? Now you have 2 sig figs. Okay? So if we're going to convert 1,000 into kilometers, we can say 1, times 10 to the third. So what we're doing is taking our implied decimal point and shifting it 1, 2, 3 places. We shifted it to the left, we've got a positive value. So 1 times 10 to the third meters. Okay. 10 to the third represents, or is represented by what symbol? So we can go to our chart. Where is 10 to the third? 10 to the third is here, represented by kilo. We can drop the K in front, and we can swap out the 10 to the third. So we end up with our answer of 1. It's not just 1. 1 km per kilometer. Okay? So we're using the powers of 10 to convert our unit into larger or smaller base values so that we don't have to include as many zeros in our number. Okay, kind of makes sense? Okay. You had one example. Let's have you do a couple more because you already got them all memorized. Whoops, sorry, almost. The ones you need to have memorized for sure. Kilo, centi, and milli. Absolutely, those must be memorized because you will see those again and again and again and again. Okay. After that, pretty much anything small is going to be a good thing to have memorized. So your deci is useful, your micro is useful, the nano is useful. You probably won't see pico. And then the mega, giga, and tera, you probably also won't see those. Okay. Again, why would we not see the large-scale numbers, the mega, giga, and tera? You're not going to work with that much material. It just doesn't make sense to memorize or deal with those units if you're never going to have to use them in the lab. Okay? So now let's go to the slide that I thought was here. So I'll give you a few, couple minutes here at most. Go through, convert each of these numbers over into scientific notation, then provide the number and the new unit. So what we want to do is convert this across. It's a good thing I didn't tell you a unit. Actually, convert it from the scientific notation. That's what we'll work from. Okay, so with the 1,000 meters, we converted that into 1 kilometer from our scientific notation. Okay. If you got questions, raise your hand. Okay, so when we go through and convert into scientific notation, each of these numbers is going to be a 1 decimal point 2. None of the zeros count because none of them are significant. If you got questions on that, review those rules. For our second value, we're shifting the decimal place 1, 2 positions, and we're shifting it to the right, so it becomes 10 to the negative 2. Next one down. All right, we're shifting it the exact same amount, so we get the exact same number, 10 to the negative 2. And the last one, we shift it 3 places, 1, 2, 3. We end up with 10 to the negative 3. Okay, and since you spent the whole weekend memorizing these, because we talked about it last Thursday and I told you to have them memorized. Okay, so with our new units, 10 to the third happens to be kilo. So we now have a new number of 1.2 kilometers. 10 to the minus 2, centi. So we end up with 1.2 centiseconds. Okay, next one. Still 10 to the minus 2, which is, again, centi. Our unit, 1.2 centiliters. And then the last one, didn't I write that one up? I guess I didn't write. 10 to the minus 3, which is milli. We have 1.2 milligrams. So the use of the scientific notation allows us to go through and say, okay, what unit do I want to use? So we're using that prefix to adjust our base unit. Okay? Questions about that? One of the reasons why I think this technique is nice is we ended up with started with two seemingly entirely different numbers in the middle two. Our 0.012 seconds and 0.012 liters. And we can convert those across using the same conversion process. Whereas if we had tried to convert seconds into some scalable version of seconds and gallons, we're going to run into issues. Okay, so our English system isn't quite as nice as the metric system. Okay, questions about that? So again, get that memorized, or at least have it up and available when you go through and do the homework. Okay, which brings up a point with the homework. Are you expected to be experts when you start the homework? No. Which means use the textbook, use the slides, use the lectures to try and get through and complete the homework. Are you expected to be an expert after the homework? It's a trickier question. No. Okay? At no point are you expected to be an expert along that system. What the homework is there to do is to force you to do some practice to get you started with the bare minimum. If you have any problems with the homework, what should you do? Find more problems to work. That's what your textbook's for. Okay? It's got a lot of questions in there. You can go through and repeat those questions to get more practice to make yourself an expert. So that when we test you on whether you are an expert or not, hopefully you are an expert and the test is really easy. Okay? The test is there to monitor whether you're an expert or how well you've mastered the material. Okay? The homework is just to get you started. Did I go backwards? Fractional notations. So this is going to start to become relevant when we move into doing our actual conversion factors. So if we look at that English, there are 1 times 10 to the third meters in 1 kilometer. Okay? So 1,000 meters in 1 kilometer. So what we could go through and do is tweak around with our numbers to drop different things in here. So mathematically, what we are saying is 1 kilometer equals 10 to the third meters. Everybody okay with that? Okay. If I have the expression 2x equals y, let's throw in another number here, 3y. How do you solve for x? Divide each side by 2. What are you actually doing to divide each side by 2? Mathematically, what you have said is you've multiplied both sides or you multiply one side by the number 1. Does that change the number? No. So what we can mathematically do is bring that other 2 by dividing both sides by that over to the other side, and we can now have both sides being effectively multiplied or divided by 1. We're going to do the same thing when we go through and look at our unit conversion. We can go through, and actually I think I've got this stepped out, we can convert that mathematical expression of 1 kilometer equals 10 to the third meters, or 1,000 meters, into this, what's known as a unit factor, at least how your textbook refers to it. So all we're doing is dividing one by the other, which mathematically equals 1. I can now multiply this unit factor by anything I want. The number's not going to change. Okay? It's still effectively multiplying by 1. Okay, what if we switched it up to a different unit? How about our centimeter conversion? There are 10 to the minus 2 meters in 1 centimeter. So 1 centimeter, again, we can drop in our numbers, equals 10 to the minus 2 meters. Again, we can convert it into a unit factor by dividing one over the other, and we end up with this notation. Okay? I can now slide this unit factor into any mathematical expression, and what I'm doing is effectively multiplying by 1. Why would I use this factor? Why multiply anything by 1? In the case of algebra with our 2x equals 3y, we're trying to solve for some term. We're going to use these unit factors in the same way, except the term that we're solving for is a particular type of unit. Okay? So we need to be able to manipulate these equations back and forth and slide them in and out of our individual conversions. Okay? Another thing I want to drop in here, because of that 10 to the minus 2, okay, for that centimeters. Okay? Does anybody else happen to remember another way to think about centimeters and meters? Because what I'm telling you is it's 1 centimeter is 10 to the minus 2 meters. Anybody else have something else memorized? Really? Nobody? Okay, well then never mind that. All right, what does that negative and the positive mean? We're doing the opposite. Okay, that's ultimately all it means. So if I tell you that if I look at a heat term, okay, and a heat just released. So there's a lot of heat that was released into the environment. And mathematically, I'm going to tell you that that release of heat is equal to negative 5 kilojoules. What if I absorbed that same heat? What does that mathematically equate to? What's the opposite of release? Hold or absorb. Okay, what's the opposite of negative? Positive. So if I want to know what happens when I absorb that same energy, what would my number be? Positive 5, what did I say, kilojoules? Kilojoules. The positive and negative there are translated in English as meaning pretty much just the opposite of each other. When we look at our decimal system, up top with our positive, or our scientific notation with our positive and our negative, what are we saying by each of those terms? The positive means, mathematically, what does that number turn into? 1 times 10 to the 2. Where did the, whoops, let's pretend that I didn't draw that. Where did the decimal start? Right after the 1. Where did it end? 2 after. It shifted 2 decimal places to the right. If I now do a negative symbol in front of that 2, what's happening? I'm just going to shift the decimal 2 places to the left, just the opposite direction. Okay?
If you were to count the number of six figs on that the 100,
Yes, we would just count the 1. So in all of our numbers, we always have an implied decimal point to specify the location of or how big our number is. Unless that decimal point is actually specified, then we can't count the zeros. Okay, so we have to be very careful. There's always an implied decimal, but when we're looking at our sig figs, we can't imply it. It has to be physically given. Okay? So if we go through and take a look at these numbers, we can look at it as 1 centimeter, 10 to the minus 2 meters, 10 to the minus 2 meters, or 1 centimeter, right? We could change that. Okay, so that minus just means that we're running that calculation in the opposite place. What's the opposite of the denominator? The numerator. So how about, whoops, that was supposed to be hand-drawn. So let's pretend I'm hand-drawing that. Stop it. Pretend I'm hand-drawing it now. Let's run that calculation in the opposite location. So it's actually 10 to the positive 2 centimeters is now how many meters? Why is it 1 meter and not 10 to the minus 2? I flipped it. I took that 10 to the minus 2. Because it says a minus, I'm now going to switch to doing that operation in the opposite place, the numerator. Because I've now done the switch, what happens to the sign? I'm going to also switch the sign. So a negative would switch to positive. Okay? And we could end up with this conversion factor. This is the one that I expected somebody would say, oh yeah, that's what it is. Let's convert this out to English. 10 to the second is, someone said it there, I appreciate it, 100 centimeters in 1 meter. Or if we go all the way into English, there are 100 centimeters in 1 meter. Okay, is that true? Yeah. Most people, so I'm kind of surprised that nobody volunteered this, happen to remember that. They don't remember this 10 to the minus 2 meters is 1 centimeter. Okay. However you've got it memorized already, you should stick with it. How I would recommend that you go through and memorize it, because I don't think I've got it handily, nope, is that you go through and you memorize your conversions according to this chart. Okay. Centi is 10 to the minus 2. Okay, always. And it's always acting on the base unit. Okay. Why would that be problematic? Well, if somebody went through and memorized that 100 centimeters is 1 meter, they can very easily swap that 10 to the minus 2 or the 100 and putting it in the wrong space. Okay. So be careful when you go through and address your units. Okay, where this becomes the biggest issue, in my opinion, is that whole King Henry George, whatever his name was, conversion that people like to remember from the math department. Okay? So be careful with your conversions. Make sure that you're consistent with your memorization techniques when you go through and set these up. Okay? So the last little mathematical test that we'll get in here, I'm going to have you guys go through and work these out real quickly. Okay? No calculator. Keep your answer as a fraction. Really quickly here. This is 3 times 6 over 2 times 3, right? 2 times 3 is 6. What can we do? We can cancel our 3's. We end up with the expression 6 over 2, which equals 3. What you're doing with numbers in each of these calculations is exactly what I want you to do with units. Okay. The problem that you're going to encounter, however, is that with units, you can't punch them into the calculator. You're all used to dealing with these numbers and putting them into the calculator and spitting out an answer and being happy with it. Okay. Units you can't punch in. So you're going to have to go through and show all of your work for each of the breakdown of the units to try and get these things to come out. Okay. Next one, the 3's can cancel and we end up with 12. Next one. Again, we can cancel, and we end up with 3/4. Right? So we can go through and look at how we can derive and break up each of these terms to be able to figure out the actual numbers. Our unit conversions must be set up similarly. All right? So you will see this standard notation where we've got numerators and we've got denominators. We could equate this as an actual conversion. If I want to, ooh, that's not going to work. Never mind. I didn't say anything. All right? So, converting answers or converting units. This is the dimensional analysis technique. Your textbook comes up with what I think is actually kind of a nice way of presenting it. It's awfully colorful, but it works. Okay, to yourself. Everybody think about this one. How many inches are in 3 feet? Go ahead and share that with the closest person to you. Everybody pretty confident with their answer? Okay. Pretty sure I only heard 36. That's good. Now the question's going to become a little bit more difficult. Did I actually step that in? Everybody did that in their head, right? Write it out. Write out the conversion that you did. Show the units actually being converted across. Okay? And I know someone's going to go through and say, well, all I did was what? What did you do? 3 times 12. Big problem with that. This is science. Every one of those numbers comes with a unit. I don't see any units. This does not work. What you've given me is a random math problem that has no correlation with this class. Drop the units in there. What are the units on the 3? Feet. What are the units on the 12? Inches. If this is the work that you give me, the question that I will ask is, what are your units? According to your units, your answer is 36 feet inches. The units did not cancel. At no point did you cross out feet or inches. The number that you're giving me at the end says that answer is 36 feet times inches. Is that what you actually meant to show? No. What other piece of information was included in this?
How many inches are in the foot?
The conversion factor between inches and feet. How many inches are in 1 foot? 12 inches equals 1 foot. We go through and look at our units now. The feet cancel. The units we're left with, just inches. Now you've shown the proper work. Okay. This is where we also get a lot of fights from people. Okay. I just made you write out a whole bunch of stuff that you all did in your head and got the answer correct. Why should we bother to show all that work? This is a load of crap. I don't want to do that. What if it's not an obvious conversion? What if it's one you can't do in your head? You now have no way to base and simplify that problem to do the conversion. Okay? And guaranteed, we will encounter a point where you cannot do that conversion in your head, and you need to write it out. If you do not work on writing out these unit conversions now, when you get to the point where it's not something you can easily check in your head, what happens? You can't do it. Okay? I know this is slow and painful to write it out. That's why it's practice. Get used to dealing with the easy stuff first because you now have an easy check. You know what the answer is. Okay? Questions about that? I noticed there was some mumbling. No questions? Or maybe it was just grumbling. Okay. How does your textbook go through and isolate this? They go through and set you up with a couple different steps. Okay? We've got a given value, our unit factor, our conversion factor, and the unit that we want for our answer. Okay? So they start out with step 1. Write down what you want for an answer. What unit are you being asked to find? Then write down what you're given. And then we want to slide in some kind of unit factor that allows for that conversion. Okay? I know this is tedious, but we're going to do that exact same problem again. following those steps. Remember, easy stuff first. What did we want for our answer? So we can drop the equal sign. This is thinking on the positive side, right? We've already got our answer written up. Okay. What was our next step? No, our next step was write our given information down. What was our given information? 3 feet. This is where I think this method is actually kind of nice. Now that we've got our given information, we look at the units of our given information and the units of our answer. Are they the same? No. What if they are the same? No conversion, and you found your answer. You're done. Okay? It is very possible that we give you a glut of information, 20 different numbers, and then just ask a really simple question, what's one of those numbers? Okay? If instead of understanding what you're reading and what you're doing, you just multiply all the numbers or divide all the numbers by each other, of course that wrong answer shows up in the multiple choice, and oh, there you go, it showed up in the multiple choice answer, it must be right. Okay? Compare your units across. Are our units the same? No. So here's the next step on dropping in that conversion factor. There's a couple options. One, you've got it memorized, which is fine. You could go through and do that. Or two, you set it up in a slightly different format. I'm going to make the assumption that there is a direct conversion between these. Okay? So I'm going to put in my conversion factor with my numerator and my denominator. What unit should show up in my denominator, which is the bottom one, right? Feet. Why should feet show up in the bottom? So my units can cancel. What unit do I ideally want in my numerator? Inches. So I'll put that up there. Now that I've got something to look at, now I'll go through and think, is there a relationship between inches and feet? 12 inches is 1 foot. You had to have that unit memorized, or that conversion memorized. Okay? How it's going to be given on an exam, because I do give you some conversions on the exam, would be 12 inches equals 1, this is going to be horrible, I'm going to do it anyway, 1 feet. Yeah. All right, where should the 12 go? I want a little more descriptive than that. I want even more descriptive than that. In front of the inches. Why in front of the inches? Because according to my conversion factor, where did the 12 show up? In front of the inches. Doesn't necessarily have to be the numerator or denominator. It could be any way that I set this equation up. So I can now drop my 12 inches there. Where does the 1 show up? Oh, you're catching on. In front of the feet. Okay. Tedious, slow steps. Everybody going like, okay, I get it. That's a dumb problem, right? Everybody? Nobody. That was a hard problem? Okay, ignore me. That's fine. I'm used to it. I'm married, right? Shoot, that was recorded. Was it? Yeah, it was. Okay, go ahead and run through another conversion factor. What is the mass in grams of a 325 milligram aspirin tablet? Again, what I want to see is the work. If you got questions, write down our unit that we want at the end. Grams. Okay. So I walked around, say about 50% of you. Good job, thank you. Okay. Those of you that didn't, that's fine as long as you get the answer right and then you don't come complain to me when you get the answer wrong. Okay. You can still complain to me, it's okay. Start with the unit that we want. What unit do we start with? We started with milligrams with 325 milligrams. Now we want to drop in our unit factor. What unit do I want in the denominator?
Milligrams.
So the denominator is the one in the bottom. I want milligrams. Why? I want them to cancel out. Why do I want them to cancel out? That unit didn't show up in the answer. The unit is just grams as the answer, not milligrams. What unit do I want on the numerator? Now the trick. What's the conversion between grams and milligrams? All right, all sorts of answers we could drop in there. The one that I'm going to drop in is the, whoops, I started doing the same mistake I'm telling you not to make. Milli stands for 10 to the minus 3. 1 milligram is 10 to the minus 3 grams. Okay. Was there another conversion factor you could have used?
1 gram over 10 to the 30 milligrams.
Also perfectly mathematically valid. I'm not a fan of this method, or the second conversion. Why? I would argue it's not even really difficult. Milli had a particular meaning, which was 10 to the minus 3. So when we go through and change our units, we're changing the base unit with that scientific, our power of 10. By throwing in the 10 to the minus, or the 10 to the third times the base unit, I'm now complicating my calculation. And I have to remember how that one slides through. Okay? You'll notice that if you talk to tutors, or even me, I already started to make the mistake. Most of tutors, or people that have gone through and done this a whole bunch, don't like negative numbers. So we start to swap the number between the units. Okay? Problem with that? In theory, you are now just learning this material. If you start to swap the numbers, you're not sticking with the unit potentially, and you may lose the unit with the number. Okay? So pick one method, and as long as you can consistently do it correct every single time, you can do whatever method you want. All right? If we go through and take a look at our units, milligrams cancel. What are our units for our answer? Grams, that was our target. According to the left side of the equation, what would our units be? Also grams, it's the only unit left, which means bust out the calculator, 325 times 10 to the minus 3 divided by 1. We now have our answer. Track the units first, then deal with the numbers. Do we want another question on that one? I got another problem there. You guys want to do another one? Sure. Okay. Am I walking you through it, or are you doing it on your own? Okay, you'll do it on your own. We'll race. So I would go through with this problem. Hopefully we got enough space on the screen. Go through the exact same setup that we went through and did before. What unit do I want to see in the denominator? Milligram. What unit do I want to see in the numerator? Microgram. So this is where it's going to get a bit tricky for those that can think ahead really fast. Do I know a conversion for micrograms and milligrams? No. I know how to convert milligrams into grams, and I know how to convert micrograms into grams. At no point do I have a conversion between micrograms and milligrams. That does not mean we give up. That just means I can't start with micrograms in that unit or in my conversion. So the only conversion I've got at this point is then converting it into grams. All right, so now I will go through and plug in that conversion. What numbers show up in front of what? Where's the 10 to the minus 3 go? In front of the grams. Where does the 10 to the minus 6 go? Not yet, thank you. The number that we drop in is our 1. Okay, what are our units now? Our milligrams cancel and we're left with grams. This is where dimensional analysis wins out. If you go through and do each of these conversions by themselves, you now have 2 lines. Dimensional analysis, we can set it up and just follow our units. I now have a new problem. I want to convert grams to micrograms. So I set up yet another conversion factor. What unit do I want in the denominator? What unit do I want in the numerator? Do I know a conversion between micrograms and grams?
Yes.
Yeah, there is one, thankfully written for us. Where does the 1 show up? Where does the 1 show up? Shows up in front of the micrograms. Why in front of the micrograms? Because I told you 1 shows up in front of micrograms. That's what that means. So when we go to our conversion factor, where should I put the 1? In front of the micrograms. Wherever it showed up, numerator or denominator, it shows up in front of the micrograms. What number should show up in front of the grams? 10 to the minus 6. What happens with the units? Grams cancel, and I'm left with micrograms. Is that the answer I want, or the units I want for my answer? Yes. Once my unit matches, now what do? Punch it into the calculator. Okay, and you should get an answer spit back at you. Those of you that want to push your mathematics skills a little bit further can go through and do another simplification. Because I've adjusted all the units, I can go through and say 325 times 10 to the third and the 10 to the minus 6 can cancel slightly. That minus 3 can cancel some of those. And we'd be left with 10 to the minus 3 in the denominator. 325 divided by 10 to the minus 3. And I now have my microgram answer, which is pretty tiny. 0. Oops. Pretty big. Sorry. 325. 1, 2, 3 micrograms. Questions? As straightforward as this one may have appeared, please type it into your calculator at least some point today and make sure that you get the same number. If you get a different number, probably the only thing that's going to happen is your decimal point is going to shift to some other place. If you don't get this number, talk to me after class, and we'll look at what you're entering into the calculator. You've got to watch out for, what's the phrasing? The order of operations within a calculator. The order of operations can bite you sometimes, so be careful with how you run those calculations. Okay, questions? Because now we do more. Okay, is everything going to be metric? Just shifting our decimal point around? Of course not. We're in America. Of course we got to use a different unit, which means if we're going to use a different unit at some point during our science, you have to go through and learn how to convert that unit at some point. Okay? Now we've got different units showing up. We don't have these perfect powers of 10 shift, okay? Which brings up another issue. How many meters in 1 kilometer? How many meters? We've got 1,000 meters in 1 kilometer. How many units in that equation? Or sorry, sig figs. I have not heard the answer yet. It is not 1. It is not 4.
2.
Not 2. Not 3. Go higher. It's infinite. This is an exact measurement. It is exactly 1,000 meters in 1 kilometer, which means the units in that conversion are infinite. They have no effect on our overall answer, okay, as far as the sig figs go. Why does this become problematic when we shift into the standard or English system? They aren't perfect measurements, okay? Sort of. 1 inch is approximately 2.54 centimeters. That's a bad example. Let's move to the pounds. 1 pound is approximately 454 grams. If you've got Google, go ahead and look up the conversion. Google spits out 453.8691 string of digits. Okay? It's not a perfect conversion. Okay? They are dependent solely on the amount of sig figs used, which means when you go through to do a problem, If you use a different conversion factor, what happens to your answer? It changes. Very, very dicey. Okay? So what number should we use to convert 1 pound to grams? How many sig figs should we include in it? Why 3? Huh? Okay. Good call. Read the footnote. Footnotes sometimes help you. With each of these conversions, we're going to assume 3 sig figs. Okay? If we want more accuracy, we'd have to look up those conversion factors to get more accuracy. So when you go through and do the mastering homework, what's your conversion factor on pounds to grams? It's 1 pound is 454 grams. If you get that question and you punch it into Google, Google's going to give you the conversion. It will be a good conversion. What's going to happen to the units, or not the units, the significant digits? Potentially change. You punch that answer into mastering, and mastering says you're wrong. But Google told me I was right. It has to do with the accuracy of each individual measurement. Okay? So be careful with these conversion factors. As soon as you shift out of the base 10 conversions, significant digits are really, really important. Okay? Another thing that the footnote said was actually interesting. The conversions on inches to centimeters, that one is exactly 2.54 centimeters. Why? Probably because we did that conversion so often that someone finally said, I'm tired of dealing with the significant digits on it. It is defined as this. Everybody listen to this. Okay? So as soon as we change unit systems, be very careful with your conversions and make sure you track your sig figs appropriately. Within the metric system, infinite. As soon as we mix systems, we're probably dropping to 3 sig figs. Okay, questions? So, of course, we got a new problem to work. Give you a couple minutes to go ahead and get this one set up as well. A lot of time. So we set it up with what we want for our answers, centimeters, what we start with, 120 yards. Set up my conversion factor. I want to get rid of yards, so it needs to show up in the denominator so it can cancel with the 120 yards in the numerator. And I want centimeters in my numerator. Do I have a direct conversion between yards and centimeters? No. Okay? That kind of sucks. So that means we have to come up with some other conversion to drop in there. What conversion is correct to drop in there? Does it have to be meters? Could be feet. Did anybody solve with feet? Who solved with meters? Okay, so we will go through and solve with meters because we had fewer people use the meters. Okay. Those of you that solved with feet actually went all the way through to a final answer? Yeah? Okay, good. So let's drop in our meters for our conversion. What's the conversion between meters and yards? 0.914 meters. So the 0.914 shows up where? In front of the meters. What shows up in front of the yards? 1. What are our units now? We're left with meters, so, sorry, Jessica, I couldn't quite hear you. What did you want to do next?
And then, like, you can just convert them into centimeters like that way.
How would we go through that stepwise? So you're right, you are going to do that. We'll drop meters into the denominator so it cancels. And what do we want in our numerator?
Centimeters.
Centimeters. What's the conversion between meters and centimeters? What's our unit? Now it's centimeters, which is what we needed for our final answer. So we did 2 conversions. Those of you that did the feet conversion, how many steps did you go through? Ooh, 3 versus 2 steps. What's problematic with that? More room for error. Okay? So there is nothing wrong with doing the 3 conversion step versus the 2 conversion step. Okay? However, you're now spending more time punching numbers into the calculator, which increases the odds that you're going to punch it in wrong, which means you'll get the answer wrong. Okay? What is the answer? I know I just deleted all my work. It's frustrating. Calculator, theory spits back 10, 9, 7, 2. Someone help me, was that the meter answer? Or sorry, from the centimeter? Sorry, 10, 9, 7, 2 centimeters, which came from, I believe, the meter conversion. Okay? For the people that went through and did the 3-step conversion, what was your answer? 0.8? 72.8, really? That was the foot conversion?
Yeah.
Oh, what was the meter conversion? 68. I knew I remembered something in there. Sorry, it's my bad. I remembered wrong. Should have written down both numbers. Interesting. What's the problem with this? They should be exactly the same. They aren't exactly the same. Okay, so we do encounter a loss of accuracy within this because we're doing English to metric conversions. The more times we include an English to metric conversion that is not exact, the more error we introduce into our number. So which of these answers is correct?
The meters.
They're both wrong. What's the answer? Oops, sorry. It is 11,000 centimeters. What? Why? I'll tell you, your answer has to do with this guy right here. There are only 2 significant digits. With 2 significant digits, I must convert either of these numbers across to the appropriate answer. My answer is 11,000 centimeters. Okay? Watch out for the sig figs. Okay? Yeah, I know everybody was like, oh, I can ignore them. Now we stop talking about them. Doesn't quite work like that. Questions? When it comes to an exam, more than likely, because they're all multiple choice, you won't run into this question unless it's explicitly asked. Or you will see multiple answers. Okay? If this question showed up on the exam, I can almost guarantee you right now I know 3 answer choices that are going to show up. 11,000, 10,968, 10,972. Okay. Yeah, that's pretty rude, isn't it? Okay. Be careful when you go through and punch in your answers. Okay. Some teachers go through and put in 1 answer and then 4 completely BS answers. I don't do that. When I go through and build exams, I put in the correct answer. Usually I do that first so I don't mess it up. And then I go through and solve the problem 4 other ways wrong. Okay. Which means all of those answers are something that you could potentially punch into the calculator.
So on the exam, do you write out the equation? It's multiple choice.
So it's multiple. So the good question. If you saw this on an exam, should you just punch it all into the calculator and get an answer? Probably not the best option, because if you make a simple mistake in your math, you have no way of verifying, okay, that you did the unit conversions correctly, be it 2 steps or 3 steps. So if you write out all of your work, you now have something to look at that you can check later. Right? If you don't have any work, then you come back to it later and you're like, oh, I don't know, sure. A looks good, B looks good. They all look the same at that point. Write out your work so you can analyze it. Remember, I said 5 short answers at most on the exam. For the unit conversions, I will absolutely ask for you to provide your work for at least 5 short answers. Well, it's probably going to be 2 or 3. Okay? What I expect to see is which was on there previously, that big long line of work. You noticed I had 2 conversions. What if you did the 3 conversion step? Do you still get credit?
Yes.
Absolutely. It is still valid. It's just a different way of doing it. I will check not that you have my answer, but that you have the correct work for getting the answer. Okay? That was fun. Questions? Okay. Compound units. Okay. Compound units are just a fancy way of looking at more conversion factors. Okay. What are the units for the speed of your car, bike, walk to class? Feel free to give me a number. I think I heard a 7. I don't know why. Actually, I think I heard a 78, but whatever. 7.8 what? What would the units be on that?
Miles per hour.
Okay. Let's be a little bit more optimistic then. Let's make that 78 miles per hour. And that's how it's written, right? What does that mean? What does 78 mph mean? We heard it, 78 miles per hour. Also known as 78 miles equals 1 hour. And then the most important version of this for us, 78 miles divided by 1 hour. Okay. Questions about what we did there? I'm going to erase all of that. This is the next fun question. I'm not a big fan of this one, but it shows up. Sig figs. How many significant digits in this answer? I know, it's kind of a tricky one. It's based on the 78. Okay, it's measuring the distance, and we assume in 1 hour. Okay, exactly 1 hour. Okay, so the 1 is infinite sig figs. Our 78 is 2 sig figs. Okay, so this conversion factor has 2 significant digits in it. Questions? I like the real sad faces. It's kind of depressing me. Okay, a motorcycle is traveling at 105 kilometers an hour. What is the speed in meters per second? Okay, so this is just a standard conversion like we've been looking at. Set it up with what we want for our answer. What units do we want for an answer? Meters per second. What did we start with? Accept that. 105 kilometers per hour. Really don't like this notation with that slash. So let me convert that into something that I think makes a lot more sense. It's 105 kilometers in 1 hour. I now have my numerator and denominator that can allow me to approach my answer a little bit better. So now let's take a look. Do we have the same units? No. So we've got to change them. Do we have to change them at the exact same instant? No. We can go through and convert the kilometers to meters, and then we can convert the hours into seconds. Does it matter when we do that conversion? No, because it's all multiplication and division, and the order in which we do multiplication and division doesn't matter. All right, so which do we want to convert first? Just said neither answer was wrong, so kilometers. In my conversion factor, where should the kilometers show up? On the bottom, because I want the unit to cancel. What unit do I want to convert the top or my kilometers to? Meters. Do I have a conversion between meters and kilometers? Okay, that's one you're supposed to have memorized. What's that conversion? 10 to the third meters is 1 kilometer. Go through and track the units. Kilometers cancel. I now have meters. Awesome. I am part way on my way to getting my answer. Okay. Next part. I need to get my hours converted into seconds. Okay, so now I can kind of blur out my intermediate calculation. And I don't even want to punch it into the calculator to get a number. If you want to, it's fine. But again, punching in the calculator is usually a last-minute thing. So I'm going to pretend that's not there and drop in my new conversion. Okay. What conversion do I want to get rid of? Hours. How can I cancel the hour unit? It needs to show up in the numerator, so it cancels. So we don't always put our units in the denominator. It depends on what we're trying to get. What unit do we want in the denominator? Seconds. Okay, this can be a trickier question too. Anybody know a direct conversion between hours and seconds? What was that? Okay, some people have got it memorized, which is okay, or can do that calculation in their head. Okay? Based on the silence, I'm going to assume no one can. So I can't do that direct conversion. What can I convert the hours to?
Minutes.
We can go into minutes. Why not days?
Because that's too large.
Does days get me closer to seconds or further from seconds? Further. I want to get closer to the target unit. So I'll do minutes. What's the conversion between hours and minutes? 60 minutes is 1 hour. What happens with my units? My hours cancel. I now have what for my unit for my answer? Or sorry, for my calculation? Meters per minute. I want meters per second, so what do I have to do? Cancel out the minutes by putting minutes in the numerator, seconds in the denominator. Do I know a conversion for this one? Yes, what is it? 1 minute, 60 seconds. What happens with my units? Minutes cancel. If I look at my overall units in the numerator, what's the only thing remaining? In the numerator, meters. The only thing remaining in the denominator, seconds. I can now punch it into the calculator. My calculator will spit out an answer, which I'm now going to hit next on. And I did not write down the answer. Awesome. So I don't know what the answer is. What does your calculator spit out? Or are you guys confident that you can enter that into the calculator?
How exactly are you entering it into the calculator?
Good thing I deleted everything. Let's see how quickly I can do this. So 105, was it kilometers per hour? 1 kilometer. Oops. No, I did that right. One hour, 60 minutes, 1 minute, 60 seconds. So entering it into your calculator, what I would recommend you do is you take everything in the numerator and you multiply it through. Okay? So in that case, we do our numerator, we get 105,000, right? The unit we would have on that would be meters. Because we're entering it into the calculator, we don't need to stress about the units. And we divide it by everything in our denominator. Until I've done this conversion a couple times. 60 times 60 gives us 3,600 seconds. Now 105,000 divided by 3,600 equals. Does that answer your question well enough? Okay. I prefer that method instead of multiply, divide all the way through it, because this way I know everything in the numerator had to be multiplied, everything in the denominator had to be multiplied. When I write out my number, I now have something I can look at and check quickly and easily when I go back through and check my work. Okay. The answer on that, anybody got a number? 29.2 meters per second. Okay. Is that the correct answer of sig figs? What did our calculation start off of? 105, which has 3 sig figs. Some people were shaking their heads. Was there something you were saying? No, that's fine. Why not based on 60 minutes? I only see 2 sig figs. At best, actually, I only see 1. How many minutes are there in 1 hour? 60.01, 59.99, exactly 60, infinite sig figs. All right, questions on that? Okay, we will start Thursday with that next question. How far did the bike get in 120 seconds? I will probably have the answer already typed up and written up on the board. So you should have that already worked out as well.